There's four fundamental forces, they explain most everything, like nuclear decay, the quantum field, and other things. So if you've ever wondered how we're floating around the sun, or how you're made of particles the same as everyone, you've come to the right place, my friend, 'cause physics can be fun, and fundamentally you're just as smart as anyone. So you're welcome in 320. Come on in, pull up a stool, and we'll start with fundamentals if you listen to these rules. Gravitational, yeah, you feel it every day. We all fly off the planet if it were to go away. You multiply the masses of two objects with a g. All over distance squared is how you solve for gravity. The gravitational force may be the weakest of the four, but it shapes the world around us in so many ways. Therefore, it's worth to pay attention to and learn about. You see, anything with mass is acted on by gravity. The short-ranged weak force is all about the quark, the elementary particle that makes everything work. Nuclear fusion that happens in the sun, and beta decay can pull apart a nucleon. The weak nuclear force helps turn protons to neutrons by changing their quark flavor, emitting neutrinos and positrons, and the weak force has two carriers, the W and the Z, and controls atoms decaying into nuclear energy. Electromagnetic is pretty cool, you see. The second strongest force, it deals with electricity, tension, friction, and elasticity, the movement of electrons and most of chemistry. Electromagnetic forces work on all charged particles. If they're moving, it's magnetic, and it's quite remarkable how the repulsion of like charges is explained by Coulomb's law. All you need to know is the charge and the distance between them all. The strong force bonds quarks and nuclei as well. Gluons hold together hadrons, and the atoms in a cell are mostly made up of three quark baryons, which have a color charges like the double quark meson. The strong nuclear force is fairly adequately named. It's the strongest of the four, although it has the shortest range. A proton's up, up, down, and neutrons down, down, up, you see. If we didn't have this force, then there would be no you or me. They explain most everything, like nuclear decay, the quantum field, and other things.